How's it going, everybody? Room for a couple more talks in your context window today, hopefully. I'm Peteris. This is Konrad. We work at Isometric. Isometric helps project developers remove carbon from the atmosphere and store it underground durably, and helps project developers deliver carbon credits. And earlier this year, we shipped a chatbot, an internal chatbot. It had basic access to our internal information, our carbon removal methodologies, and API docs. And we announced it, we gave it to the teams and said, go for it, give it your best questions and see how useful it is. Just do your worst stress testing it. And they did. They started asking lots of questions. They started seeing clear value in the responses that they were getting. And some of the questions the AI assistant could comfortably answer, and some it could not. For example, it could tell you how to deliver direct air capture credits with Isometric, but it couldn't tell you which scientists worked on this pathway or how many credits we issued last quarter. And that's, of course, because that's all product data that's already available through our APIs and internal tools. So it's only expected that folks would want to ask questions like that, but it was not yet accessible to AI assistants. So how could we connect AI assistants to internal information? And how could we do that in a low overhead way that actually scales? And of course, we do already have these robust APIs that are well tested, that have considerations for content rules. So how do we leverage these for MCP? Is that even possible? Spoiler alert, yes, you can, of course, but it was a journey to get there. We gave it a few different attempts and we learned quite a lot along the way. And so we'd like to chat to you about that today. As a quick refresher, this is probably not going to be news to anyone how MCP servers work, given there's been a few talks on this topic today, but you can use any AI assistants such as Claude or ChatGPT or Gemini, connect to your MCP server and have the MCP server expose tools that give your domain information to the AI assistants. And that's also what we did. But you can also build your own MCP client, which is something we did. It's called Remy. And we chose to do that to have fine-tuned tool execution control and to be able to choose any model, which worked quite well. And so how do we give Remy access to our internal data? Our first iteration was to build dedicated tools and retrieve the data that we want. And it looked something like this. So we have our database entities, we've got credits, deliveries, organizations, and project developers or suppliers. And some of the tools are quite simple, like list deliveries, list credits, get the details for a supplier. But most of the time we found that you really need more than one, more than two sometimes tools to really clearly answer the user's questions. The more questions we wanted to answer, the more tools we had to maintain. So the list grew quite quickly, and we started seeing some cracks in this approach, which we'll get into in a minute. First of all, multiple tools per user story, so which means large tool definition immediately in your context window, which degrades the accuracy and usefulness of the MCP server as a whole. Also, we found that returning useful answers often required chaining tool calls. So these operating in multiple turns and adding to the context window every time, again, added noise in the context window that was not necessarily useful. And there's also more room for error in every turn. The output data model with this approach was also quite rigid. We either had to go for something very hyper-specific to return a very precise, concise tool call output to the AI assistant, or we would have to put more strain both on a database as well as more information in the context window by always returning as much as possible. And finally, of course, the API boilerplate. As I mentioned, we already had a mature API that, with good considerations, good architectural decisions, we didn't want to re-implement it in a very similar way for MCP tools again. So there are some downsides, but moving from these N+1 problems to my +1 on stage, Konrad is going to talk about how we solve these challenges in a couple of other attempts.
Hi, I'm Konrad. I work with Peteris on AI at Isometric. So the problems that we've seen here felt quite systemic. And we ask ourselves the question, is there a systemic solution to them? So can you come up with some sort of high-level framework or abstraction that will solve them by definition? So we gave this hypothetical solution the working title of AgentQL. What would the properties of AgentQL be ideally? First of all, we'd like it to be flexible and client-driven. To solve the problems that Peteris spoke about, it would need to, for example, do things like nested lookups to avoid calling tools multiple times, or have the ability to control very precisely what data is returned. Say you are working on some administrative task, you may be interested in the organization's legal address. But if you're doing a security investigation, you want to look at their admins. Additionally, we would want to have a very clear and succinct spec. LLMs really thrive when given documentation. That's why more on the websites have the llms.txt file. And our solution would need to make it so that agents can understand what's possible and how to work with the server. And then finally, it would be very convenient for it to have the ability to try run things so that you can understand if your hypothetical query would work without having to go through the pain of actually attempting to run it on the server to drive much quicker iterations. As we were thinking about our agent QL, we realized that we are redesigning something that already exists and is called GraphQL. So GraphQL is a data query manipulation language originally invented at Facebook in the early 2010s. And it has got many properties which match almost exactly what we want. So first of all, it's driven by a clear spec file that you can see here on the screen. So this is an example of a GraphQL schema file. It's a simplification of our Isometric internal GraphQL server schema. And it tells the client everything that the server can do. In this example, the query on top tells you about all the entry points to request data from the server, and the types below it tell you what relations you can follow, what different fields or objects mean, what are the exact types, etc. Every possible query can be derived from this and also validated against it. Going from theory to practice, here's an example interaction between a GraphQL client and server. So on the left here, you can see an example query. Every piece of data that's requested is fully controlled by the client. It has things like the ability to follow relations. So if you're interested in learning more about the delivery of carbon credits and you want to know what organization performed the carbon removal, in our data model, you have to go from delivery through a supplier all the way to an organization. And that's possible very easily in GraphQL. And then finally, it has nice perks like the concept of fragment, which lets you reuse some logic and fetch data consistently, regardless of where it's requested in the query. So a query like this would give you a result like this in our server. This is a real output data blob, and a client can understand exactly what it means because it's requested every field, and it can cross-check it against the spec precisely. So the summary is that GraphQL gives a lot of power to the client. And in our case, the client is actually the LLM. Now, we think it's actually very good that LLM has a lot of power because large language models are good at solving novel problems, and they can construct a GraphQL query to solve some sort of a user question that they have never seen before and possibly will never see again. And there is no need for a software engineer to anticipate the exact shape of data that they will request and store it in the source code. It just works fully client-driven. So it's a very powerful tool which underpinned the second attempt of giving our internal chatbot information about the business. Rather than having a large suite of tools, we wanted to have just two generic tools that enabled the agent to communicate with our GraphQL server. So they ultimately also spoke to our internal tables, service, etc., but this time through the layer abstraction of the GraphQL server. So anything that was implemented in the server, you got for free through these tools. And they are split into query and mutation tool, because one allows you to read data, whereas the other one allows you to edit it or mutate it. Armed with this new architecture, we have updated the base prompts of our assistant to ask it to introspect the schema of the server, to understand what is the precise query that it should construct, then run it, and use the response to answer the user's question. I'm going to have to make a small detour into one more advanced GraphQL functionality to explain this new term that you've seen on the slide, which is introspect the schema. So the thing that you see on the left here is this static GraphQL, the thing that you can see on the left here is a meta query, which requests from the server information about its functionalities. So the data on the right is somewhat equivalent to what you've seen in the spec before. It's just a different format, but it describes things like the available data, fields, types, descriptions, and whatnot. So our hope was that things would work this way. The agent would, given a user's problem, introspect the server, learn about the server's abilities, use it to then construct on its own the appropriate query, run it, and then synthesize the answer to the human. The reality ended up being quite a bit more complicated. So the agent made a lot of mistakes. It had to iterate on the query. Sometimes it did it on its own. Sometimes it went back to introspection. Eventually, more often than not, it did get the answer, but it was with quite a lot of pain. It not only caused simply bad user experience, but also polluted the context with all these attempts, many of which were failed. We weren't particularly happy about this, but we set out to diagnose the cause of the problem, and we managed to pinpoint it to the way in which the agent learned about the capabilities of the server. So on the left here, you can see the original schema, static schema file that I showed you first. It's very concise, describes everything that the server can do. And on the right, you can see the schema introspection results. What you'll notice is that in approximately the number of characters, which describe the entire raw schema, we have learned that there is a type called delivery and has one field called ID and description, ID. The information density in this second way of learning about what the server can do is much worse. And this, coupled with the fact that we actually had to also insert it into the only conversational loop that there was, which was the main chat between the user and assistant, meant that the LM just simply couldn't handle it. So I'm going to hand it back to Peteris to talk about how we iterated on this and made things work.
Nice. So we had one more idea, which was, what if we could move things off the main loop into a subagent? So the architectural change that we made was this. We added a new tool called How to GraphQL, and we added a GraphQL subagent in our MCP server, so the tool would talk to this agent. And we updated our base prompt accordingly. So now, instead of saying introspect a schema, we said use this How to GraphQL tool to construct your query and then answer the question. And what it looked like now was a tool call that provides some information to the subagent. And then again, the subagent has its own completely separate loop from the main loop. It can talk to an LLM of our choice, which will be best suited for for constructing a really useful query. It might take a few attempts for the subagent to validate this query and return something that's really useful and executable. But all of that is kept off of the main loop. So we're not polluting that main context, and we're returning a single, precise, useful query. The AI assistant can then execute it with the same tool as before, and we receive a nice result. And so zooming into the subagent again, as inputs, we gave it the user's original goal. We gave it some context as well around the goal, and based on the conversation so far. So the LLM, the main loop AI assistant, would interpret the conversation and add some more specific context to the subagent as well. And we also included previous attempts, which might be as failures. And again, in this case, not because of schema validation, but because we might have some limitations or client errors on the amount of data that the query can return or can be requested and things like that. Still useful context for the subagent. And there's a simplified version of the prompt that we gave the subagent. It uses the schema, like Konrad described just now. That was one of the clear advantages here. It knows the user's goal, it's got the context, it's got the previous attempts, and it's got a tool to validate the query. And it can return a suggested query with also some additional comments. We found that outputting the additional comments was also useful for things like, this is how you handle pagination, or these fields might be relevant, especially if to answer this question. So we thought about how to pass context both in and out of the subagent, given that it is a completely separate loop. And we found that it worked quite well. So here's a quick recording of Remy and the user question about the deliveries, the same delivery ID as Konrad demoed earlier. You can see that the main AI assistant calls the How to GraphQL tool with some relevant inputs, receives a precise query for this question with some additional comments, and then returns nice, useful data to the user in 14 seconds. So pretty nice experience in the end. And Konrad's going to take it away with some takeaways.
Thank you, Peteris. I'm going to start with a few technical observations. The first thing that we learned is that LLMs understand GraphQL very well. This was good news, not only because GraphQL met our needs, but it showed that it clearly is a part of the trained data of virtually every main model on the planet. So we didn't have to build any custom instructions to teach the model how to use it. It just knew it by default. And that's very useful learning for that. If you can use something that's already built that models know about, you should just do it, as it makes your life much simpler. Also, like I said before, raw schema worked much better than performing the schema introspection. And the key quality of the raw schema was its conciseness. So at present, our raw schema takes about 50,000 tokens, which is not a small number, but it fits well within the limits of modern fast LLMs, which are more about 1 million tokens. And it would be and it contains the complete information about the server. It would be impossible to do the same thing with the schema introspection result, which uses a JSON format and repeats a lot of information unnecessarily. So pay attention to how you condense your information to avoid bloat. On the topic of avoiding bloat and protecting your context window, subagents are an extremely useful tool at this. So they not only improve the performance by being able to craft a very precise prompt for a very precise problem, but also hide all the unnecessary or confusing complexity from the main loop. So this is not just failed attempts in the way, but for example, this 50,000 token large schema. If we put it in the subagent, you can actually put it at the very top of your query, and as a result, it will cache across multiple invocations. This would be impossible if you wanted to put it into the conversation history, because there would always be a different previous messages prefix, and caching wouldn't work as it normally does. And then the final point on the agents or subagents is that it's very important to pay attention to sharing the context. So we didn't build a subagent that simply gets a task and returns a response. The main loop agent gives it a lot of additional context. So previous attempts, any additional context that the LLM just comes up with based on the history of the conversation. And then similarly, the output is not just, here's your query, it also includes comments. As a result, whenever there was a need to iterate on something, the subagent would pick it back when it started, rather than spin wheels and suggest again something that was tested not to work before. So now to come back to the original question, yes, what are our learnings about effective ways to give AI assistants access to internal information? There's a bit of a debate about it in the community, especially around the model context protocol. So some claim that it's actually unnecessary, that LLMs can just call APIs already exist, and MCP is pointless. And then you have views on the other side of the spectrum, which say that you should not expose your existing APIs to LLMs because they're not built in an AI-friendly way, and you should instead build agentic tools. Let's look into those two views guided by our experience. So it's definitely true that existing APIs have the huge advantage of already being there. We have seen it with our own eyes and fingers at Isometric. And they additionally have a lot of useful things built around them. So you have toolchain to deal with things like security, testing, observability. This is all very valuable. On the other hand, MCP is not just about forwarding API requests. It adds useful annotations. So in this particular case, we created a query tool, an imitation tool, and the query tool was annotated as read-only, so the model knew that it's safe to call it as many times as it wants. However, the imitation one was labeled as potentially doing the dangerous things. So that's important. And finally, MCP is not just tools. So it also contains advanced features. For example, the sampling functionality would make it possible to move the execution of the subagent from the MCP server, which is the case right now at Isometric, to the client itself. And this has some really nice consequences when it comes to, for example, inference cost for someone running a popular public MCP server. In short, we think that these two approaches each have their own merits and work best when combined in an intelligent way, which is something that we hopefully demonstrated in this talk. So I'm going to end it here. Thank you so much for paying attention to our talk. And thanks. We are open to questions, but before we do this, we'll just make a cheeky note that if you're interested in climate and applying AI to various problems, we are hiring. Thank you. How should we do it with the...
First of all, thank you so much. This was really cool. Questions? Oh my God. Okay, let's go.
Thanks for the presentation. It was amazing. Just got a question. Do you have any GitHub or some example of this kind of thing? Because I understood generally like how you do it, but actually putting it into like motion, I have no clue what's.
The unfortunate answer is not at the moment.
Fair enough.
I think we may publish a blog post about it, or at least share the slides.
That'd be great.
Yeah.
Yeah. Thank you.
Yeah. We do have a public MCP server, which will eventually also implement the same thing, so you'll be able to play with it. Watch our LinkedIn. Good shot. No, we're just going to announce it on LinkedIn, on the company LinkedIn. But because the thing that we have here right now works internally.
Oh.
But we also have a public MCP server for people to learn about our company and.
Great talk, thank you. How did you go about handling like the identity of the user through the system? Because you're exposing tools that probably not everybody should be able to call at the same level.
Yeah, that's a good question. So we in short, we handle it through user level authentication. So even prior to the GraphQL toolset, we already required user authentication when using the MCP server, and we simply pass it through to our internal GraphQL service. And it works the same way as it would if you were to call it as a GraphQL client over the web.
Thanks again for the talk. Technical kind of nature of MCP. MCP tends to use a lot of RESTful APIs, but when you get into something with GraphQL, you could utilize subscriptions. Has your company looked into anything where you've got like these long-lived connections where maybe the MCP is keeping that connection open to GraphQL to constantly stream data back and forth for any kind of queries? Or would there be any good use of that in what you've built?
Do you want to take this?
Try and hold
That's a hustle.
Can I do this work? Okay, cool. Yeah, I guess the short answer for this use case, we were interested on just immediately returning these answers. Subscriptions is something that might be more relevant, I think, in our own dashboards and our public products. We hadn't really considered it in this context yet, but there might be something more interesting in the, I think, in agentic space, agentic execution rather than a chatbot execution.
Something like that. Sorry, just for the recording, utilizing something like the subscriptions, but also interacting with something like MCP UI to like auto visualize the data that's coming back in some way.
Yeah, we haven't explored that yet. I think I guess to talk a bit about technical implementation, we're using AI SDK and we are streaming back the tool responses where we can. We haven't attempted doing any long-running tasks and then returning that information, which I think is maybe the direction you're heading. I think that's something that might be relevant again when we apply AI deeper into our product, which we are also doing into our main product that our product developers use. But this is for this internal chatbot, we haven't explored that.
Question from my side. So in your final solution, how did the LLM get the GraphQL schema? So did it get it via the Subagent? And in this case, if the LLM asks several questions in a row, does it need to get the schema every time again? So do we waste kind of the context with this, or how did you solve this now?
I can take this. So the main loop agent doesn't know the schema. It only asks the subagent to help it solve a problem. And then we inject the schema as one of the first messages in our prompt to the subagent. So if the main loop agent has a few questions, it has got two options. Firstly, it can call the subagent tool with a number of questions, and the subagent is going to hopefully solve all of them at the same time and give it a response to each of them one by one. It can also issue multiple tool calls in parallel or in sequence, and it will kick off a new subagent run. However, because of the way in which we order things in the prompt, we will cache the reading of the schema because it comes before the actual question. So we are quite token efficient in this way.
One more question? Okay.
So before you move to this subagent solution, you commented that the introspection schema was a bad format for the model to understand. Did you consider just changing your endpoints to return rather than the structure returning a string which is the same the human readable version?
So we thought about it. We decided to go to subagent because we had an intuition that it would work better for other reasons. If we gave the main agent the entire schema, 50,000 tokens is quite a lot. So we think that this still would have been a problem. For example, we did this previously in Cloud Desktop, and we actually hit limits in the tool response size. So I guess what we could have done is we could have built some sort of schema exploration language, which is an alternative to the official introspection API, but we just decided to dump the entire schema in a subagent and do it this way.
And also to add that, I guess the other reason we did this was to remove the iteration from the main loop. And especially if you're using an MCP server, just seeing all that noise and all those failed attempts degrades the user experience and pollutes the context. So that was another reason. But yeah, technically, I think maybe that could have worked as well. If your schema is smaller, maybe it's worth trying for your use case.
The subagent sees the static schema, so the human version. It's much more concise.